Hello everyone, welcome to my chemistry channel. We are the short and sweet in chemistry. Now I want to explain for the class 10th, that is the formation of covalent molecules. And now here cyclopentane and ethane. In part 6 also I have explained the formation of covalent bonds in cyclopentane. But I hope it may confuse to you. That is why again in part 7 I want to explain step by step how can you feel easy to draw the electron dot structure for the cyclopentane. When you see, you want to draw the cyclopentane structure, first you should remember what is the formula of cyclopentane and what is the structure of the cyclopentane. That means how many hydrogen, how many carbons are present here. Now, here also I told carbon, that is cell is K and L, that K occupies 2 electrons, L occupies 4 electrons, the outermost cell is 4 electrons. So it is necessary to add 4 electrons more for sharing. That is why it can attain the inert gas configuration. Now, if it is the structure of cyclopentane, then you expand in this way that 1 carbon is attached to 2 hydrogen, then 5 carbons are there, and now here then 10 hydrogens are attached. But you can feel how many covalent bonds are formed between what? CH. You can find 10 covalent bonds, that is about CH. You can calculate here how many CH, that is 10. That means 10 covalent bonds above CH. Then 5 covalent bonds above C and C. See here, this C, again one C, here. That means there are 5 covalent bonds formed between C and C. That means totally how many covalent bonds? 15 covalent bonds are there, and 10 are CH and 5 are CC. When you remember like this, then you can feel easy. Then you see first step. Here I want to show you how the bonds are formed between C and C. Here, see how many? 1, 2, 3, 4, 5. That means you can see, 4, 5, 1 and 5, 1, 1. That means here how many pairs are forming covalent bond? Here 1 pair, 2 pair, 3, 4, 5 pair. That means here 5 pairs of electrons are used for sharing and form covalent bond. What is that covalent bond? CC. Now see, here I put the covalent bond sign, and this is the covalent bond between C and C. Now in second step, I want to show you between carbon and hydrogen. See, one from carbon, one from hydrogen. Similarly, here I have put in a red rounder. Here one from carbon, other from hydrogen, and it forms how many? 10 covalent bonds between C and H. Here you can see 5 CC bond, and here you can see 10 CH bond. That means lastly we will see how the carbon satisfy inert gas configuration near to carbon, that is here neon. Similarly, here also you can observe that between carbon and hydrogen, the pair of electron is for the hydrogen will satisfy the inert gas configuration of helium. Helium is a special one where it attains the inert gas configuration only by 2, not by 8. See here, carbon 2 to 4, 2 to 4, 4, 8. That means the red rounded you can find 8 electrons. That means carbon outermost cell electron 8 satisfied. Similarly, see second. Here also second round you see red round, and here also 8 electrons. Here also 8. Here also 8. That means each carbon satisfied by 8 electrons in outermost cell by the nearest inert gas configuration of neon, where it is 2, 8. That means here L cell occupies 8 electrons. That means here outer shell occupies 8 electrons, and also carbon also occupies the same inner gas configuration of neon. Here you can find, if you remember this, then this, then easily you can write inner gas configuration here. Now inner gas configuration of carbon, how it will satisfy by the 8 electron. Now it is clear. That means here, first one you see how the bonds form between carbon and carbon. In second one, you can see how the bonds are formed between carbon and hydrogen, and how the hydrogens are satisfied by nearest inner gas configuration, the helium. And third step, I want to clear how the carbon is satisfied by the 8 electrons near the inner gas, that is neon. Now it is clear. You can write directly this one, or you can, now I hope you can understand from the beginning what step by step and how the bonds are formed. I hope it is clear. The covalent molecules cyclopentane, or you can say electron dot structures of cyclopentane. Next we will see ethane structure, electron dot structure of ethane you can say, or you can say formation of covalent molecule, that is ethane. Ethane. Ethane means C2H6, that is molecular formula. Here see how many carbons are there? 2. And how many hydrogens? 6. Atomic number of carbon is 6. And electronic configuration 2, 4. K cell occupies 2 electrons. L cell occupies 4 electrons. This is the electronic configuration of carbon. Atomic number of hydrogen 1. The electronic configuration is 1. That means K cell occupies 1 electron. When you will draw the covalent bonds in ethane molecule, or you can say when you will draw the dot structure, electron dot structure in ethane molecule, you should remember that means what is the structure of ethane. If you remember the structure of ethane, automatically you can write easily that electron dot structure of ethane. So it is my request to you all, please remember ethane structure. This is ethane structure, and it is the atomic structure of carbon, where K cell occupies 2 electrons, L cell occupies 4 electrons. Similarly, here this is the atomic structure of hydrogen, K cell occupies 1 electron. Here only 1 electron required to attend the inert gas configuration of helium, and here 4 electrons are required to attend the inert gas configuration of neon. That is why first you know this formula, then you remember the structure, what is the structure, possible structure, and this is actually correct one. And here how many bonds are there? 1 CC bond and 3, this side right side CH bond 3, and left side also 3 CH bond. The total is 6 CH bonds and 1 CC bond. That one you should remember. Then automatically you can write the electron dot structure of ethane. Now this is the carbon, there are 4 electrons in the outermost shell, 3 this one and 1 this one, and here this carbon, here also 3, 1, that is 4. That means here what happened? Here you can see hydrogen also 1 electron, these 3 hydrogen having 1 electron, right side also 3 hydrogen having 1 electron each. They are far away from each other, but when the covalent bond is going to form, they come to close each other and they try to attain the inner gas configuration, nearest inner gas configuration. Now here they are close to each other. They will come close to each other. Then you see this carbon and the carbon, there is a pair of electrons for sharing and forms covalent bond. Similarly, the carbon and hydrogen, between carbon and hydrogen, 1 pair electron. Similarly, how many pair? 3 pair electrons between the CH and CH. That means the 3 pair of electrons are sharing between 3 CH. 1 C and here bonds are formed like this. This side also, this one carbon, and that is close, that electron come to close to your hydrogen electron and try to share the pair of electrons for covalent bond. So here how many? CH, CH, CH. 3 pair of electrons, and they will share and forms covalent bond. So this side also you can find 3 covalent bonds, CH, 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 and that right side also there are 3 bonds, CH, CH, CH. That means here you may conclude that this CH, 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 and how many total covalent bonds? That's left side 3 covalent bonds, in middle 1 covalent bond, and this side 3 covalent. Total how many covalent bond? That is 7 bonds. 7 bonds will form. Now here 7 bonds. Out of 7 bonds, 1 is CH and other 3 are CH bonds. So 6 hydrogen atoms have 6 electrons, you can observe here, and 2 carbons have 8 electrons, because here you can see the dots, that one is for carbon and that cross one, that is for hydrogen, and you can clear this one. There are 4 electrons surrounding carbon. There are 4 electrons surrounding this carbon and 1 hydrogen, 3 hydrogen, they represent their electrons. And this side, left side also 3 hydrogen represent their electrons, but when they come close each other, this carbon form one covalent bond between C and C, and right side you can observe there are 3 covalent bonds, that is 3 pair of serine, and here 3 CH bonds are formed. Similarly this side also same, and you can find whether the electronic configuration of nearest electronic configuration followed or not. Yes, you can check. 1, 2, 3. 3 pair means 3 into 6. 3 into 2, 6, and this one 2, 8. That means this carbon satisfy the inert gas configuration, nearest inert gas configuration, that is neon. Similarly, this carbon you check. Here, this carbon 2, 3 pair and 4 pair. 4 into 2 means 8. That means the outermost cell that is having 8 electrons and it is attending the nearest configuration that is of neon. For hydrogen also you can check it. For hydrogen, 2 electrons are there and it attains the inert gas configuration of helium. Now helium, that is the inert gas configuration, but it is special one. It will attain the inert gas, that is 2 electrons. It has 2 electrons, that is why this hydrogen satisfy the inert gas configuration of helium. Similarly, 6 hydrogens, they are satisfying the inert gas configuration, nearest inert gas configuration of helium. Helium is a special one in the inert gas, that is 18 groups. Though it has 2 electrons, it is not having 8 electrons. It is only 2 electrons. It has only 2 electrons, and also that is inert gas, that is helium. So I hope this bond it is clear. There are 7 bonds. One is between C and C. Other 6 bonds are between C and H. So I hope it is clear to you, and if any doubt you can ask in my comment box, and I hope you will subscribe my channel B.L. Das Short and Sweet in Chemistry, and hope you will share and like my channel. Thanks for watching my video.